Hey everyone, so thank you very much and welcome to our little talk on Neo4j's risk register, so maximizing your data insights. So quick introduction to what we're doing here. So this is a proof of concept little information security project that we had here. I'm going to give it a little bit of an introduction, a bit about the background of the project, some quick look at the data modeling that we did, the applications, and then some of the future work that we're looking at going forwards. And then I say we, but Will here is the brains behind all this. So I'll start by introducing myself, a little bit of background to me. So my name is Phil Stott. I'm Senior Manager of Support Operations and Enablement here at Neo4j, which generally means globally I look after the support team in terms of tooling, training, and sort of technical resourcing there on the side. Will, do you want to go ahead and give a little introduction to yourself?
Yeah, sure. Thanks, Phil. I'm a third-year computer science student, and I'm currently studying at Durham University in England right now. I love all technical things. I'm a bit of a nerd, and actually I came to Neo4j last summer. We're kind of tasked with this project of how do we, can we convert some tabular risk register into a graph risk register? And that was a really cool problem that I enjoyed working on. Yeah. Phil, would you like to explain a bit more about what the problem was that we worked on?
Yeah, sure. Thanks. So first of all, like internships at Neo4j is something very close to my heart. We have our summer placement students, engineering students from computer science coming in. Will be an example. I've worked with many others over over my time here, and this is very much about promoting, working with sort of our future as a profession. Computer engineering is a profession. We need to grow it for the future, so that's what we do here at Neo4j. So I'm really interested in this. Puts me in touch with a lot of cool people, and the future is very bright, as I'm sure as you watch Will's presentation here, it's going to sort of showcase what's up and coming. So our Chief Information Security Officer, Dave, actually approached me and said, "Hey Phil, can you do a little bit of training? And I've got this project. Going to have an intern come in. It's going to be about 8-9 weeks, and we're going to take our tabular risk register and put it in the graph." And in my usual style, I quipped something along the lines of, "Well, that's only a day's work. What are we going to do for the rest of the time?" And Dave was like, "Oh," and so we got into talking about, we could do structured data. So I was absolutely sold on this. So Dave provided this quote, which I think sums it up quite nicely. It's, "Traditional risk registers are typically tabulated. They silo each risk and see each risk only in the context in which it is described. It's a narrow view." So what we're saying there is, if you think about your risk register as just being rows in a table, and maybe this is a spreadsheet for a lot of people, or it could even be an online document, then traditionally we end up stuck in these problems of inconsistency. So the way that I might report a risk, if I was a risk analyst, and somebody else reports a similar risk, that could be quite different, and we end up with this inconsistency in the data. The metrics we use to describe the risk can be very arbitrary. My thoughts on a high risk, somebody else's thoughts might not actually be the same. We could use an external guide, but that then isn't really always reflecting the data that's already there in the risk register. Duplication can be a major one. So if Will and I are risk analysts and we both take a report for, let's say, the risk of theft of a laptop, my laptop could be one report, somebody else's laptop could be another report. But handling risk of theft is handling risk of theft. We don't need a separate mitigation. So again, if this is just rows in a register, then you need to do a lot of manual work. And then this siloed thinking, you can end up in this world where, let's have a look at how something is, the way that risk on that asset is in its own bubble. And then you don't think about what that laptop's connected to, what impact that could have, downstream problems, things like that. So you can end up inherently focusing on the way that the we record risks and the process rather than going through it. So why graphs, I think, is where we're going here. So risk is concerned with relationships. It's risks applying to relationships. It's relationships between risks, like relationships between assets. And at Neo4j, we always say relationships. We value relationships. Relationships are a first-class citizen in our database. So if we start to use graph thinking, then we sort of encourage this different way of looking at things. We look at this as connected rather than silos. An example, attackers might actually think in terms of graphs, whether they know it or not. And by that, we mean if somebody's looking to exploit a business, then they could be looking at what is the maximum impact they can do for the minimum amount of effort on their part. And so that could actually be summarized as a graph problem. And actually, on the other side, a lot of the leading cybersecurity tooling we have today relies on some form of structured graph modeling. How do we work with those? So we had some project goals. And we could summarize this in almost 3 phases. First of all, the Phil's one-day quip, modeling in Neo4j. Let's convert the tabular data to a graph model. Can we do it? And I say, yes, I think we can. The main cut and thrust of this is, can we answer new questions based on the information in the risk register? Not adding more information, but on the information that's already there, represented in a better format. In this structured graph, can we do this? And through that, conclude, do graph databases aid risk management decisions in the way that we think they should? And so all graph problems in Neo4j will start with a level of data modeling, getting the graph structure right. And by right, I don't mean perfect. Things don't have to be perfect for a proof of concept. It's about making it work, and then you would iterate. So in terms of goals, the model imitates life. So this is quite a strong principle that if you're building a digital twin, so you are representing the real world inside your graph, then you should model it in that way so that somebody who's familiar with the domain, so a risk analyst, would understand what's going on. If you abstract this too much, then the intuition gets lost along the way. So we model the risk as close as possible to the real world. As I mentioned, it's about preserving the information in the risk register. Changing the risk register and the information within it is out of scope here. It's about preserving the information we have in the traditional register and looking at that in new ways. And part of that, therefore, is adding structure to that data through the use of the graph schema. And we're not a strong schema database in Neo4j, but by applying some graph schema, by defining ourselves what nodes and properties and relationships we have, we add some structure to support more data. So going forward, adding more information and also the richer analysis of the data that we have. Then beyond that, we start thinking about things, and quite often I summarize this as sort of nouns as nodes. The concepts, the objects, the things we talk about, they become nodes in the graph. These are the vertexes. Then we have verbs as relationships. So the actions, the way these objects and concepts and things interact, those are our verbs. These are reports, effects. These are relationships. And then our additional information. So when we talk about an asset, what asset? When we talk about a person, what person? Those become properties. So based on that sort of thing, we start with the nouns as nodes. What are we talking about here in the risk register? We've got risks, we've got assets, we've got a person or people in plural, and these are the objects we have and how they interact. So a risk affects an asset. And we see that a risk is a node and affects is a relationship with a type of effects. A person uses an asset. Maybe a person could own an asset. And a person reports a risk. And we can see that it starts to become very intuitive the way this works. And then we add the additional information. So the asset is Phil's laptop. The person, Phil's Stott. And the risk is theft. So this we can very quickly see is Phil Stott is reporting there's a risk of theft of Phil's laptop. And you don't need so much domain knowledge to understand where this goes. So based on this starting point and some simple lessons, I left it to Will to build a graph model that represents the risk register they had. So Will, do you want to go ahead and feed us some information on that?
Yeah, cool. Whenever we start thinking about modeling this, especially as a risk register, it seemed to make sense starting with a risk node and then building out from there. So as you can see, we started with a risk node. You can start to add things like, say, people. A risk was reported by a person. Then from this, we can start to see kind of more information, like how many risks has a certain person reported, what type of risks have they reported, these kind of things then start to become more apparent even just by adding two nodes. We can add different things like a threat threatens a risk, or a vulnerability creates a risk. And then we can, sort of examine the relationships between these, expand them, see how they interact. We can even see, this looks slightly more complicated, this one, but I promise it's not too bad. You can see the relationships between business units and assets. And the way we've defined it in our risk register is a risk will have a primary impact on an asset. And then that asset will be used by a business unit. The cool thing about graph structure is you can sort of define things a bit more loosely. So a risk could primarily impact one asset, but have multiple secondary impacts to other assets. Kind of examining this relationship is really cool, and we get into some applications that we'll talk about a little bit further. Also, another cool property of graphs is you can start to add time series data really neatly. Things like reviews of a risk. This just wasn't captured at all before, but thanks to these sorts of chains that you can form, you can start to append new reviews onto each other. So say the first review might have an earlier date, and then so on and so on. You can add different information. We update the impact ratings and the probability ratings of risks. This is captured here as history, so we can view these in the future and see why we made those decisions. This is also captured a little bit in this subgraph, where risks have analysis. The idea of this was kind of more future-proofing, where you might have maybe multiple analyses, and then someone needs to approve an analysis for it to actually be applied to that risk. You can then have a plan for risk. And again, the idea was to future-proof it at the moment, future-proof it a bit more. So currently we only have one plan per risk. That seems to be consistent with most risk registers nowadays, but it develops the idea that you can have one plan that treats many risks, or multiple plans for one risk. That kind of thing is now easily expressible through a graph. And again, you can see the sort of next progress thing, true or false. So you can open a risk, close a risk, and then you can reopen it in future and still keep all of the information that was previously there without losing it. Cool. When you put this all together, all of these subgraphs, you get this really complex view of what a risk is. This is just a row in your spreadsheet normally. But whenever you put it all together, you get this much more complex set of relationships and nodes. This is a much more complex picture, allows you to gain better insight. You don't have to just look at it like this every time. Again, we'll talk about some more tools that you can do some data analysis on. But for example, you can just expand certain nodes. You can look at the relationships between vulnerabilities and threats, vulnerabilities and risks, examine these relationships, try and find patterns. And again, it's also worth mentioning that a well-designed model is key to many of these applications. So we spent time kind of developing this model and making sure it works, because without it, we wouldn't be able to do some of the more advanced applications. It's also worth mentioning that this model is typically reiterated over time. So we might say, hey, we need this feature. It's not properly encapsulated by our graph currently. How do we go about adding that? So it is an iterative process. But let's go on to some more data analytics we can uncover from these graphs. This is actually the demo risk register that we've prepared. It's no longer a spreadsheet anymore. This is it. It's a graph. It's a 3D graph. There's some nodes on here. You can see, well, the orange node, I'll tell you, is a person, and then the green ones are risks. And you can see that person has reported loads of risks. So you can start to ask questions like, why does that node have so many connections? What are those connections? Is that important to the business? It's really easy to notice these relationships, where that's something you'd not be able to easily spot whenever you look at a normal risk register. So yeah, examining these relationships between different properties of risks is really, really key. We also have a module as part of Neo4j called Graph Data Science that I thought I'd cover, just because it puts these notions into, it kind of quantifies them. So we have certain algorithms to express if things are clustered together, if things are important, like if many relationships go through them. There's these sorts of algorithms that exist that can quantify those sorts of notions that we have when looking at graphs. So you can do these sorts of things automatically. Yeah, so it's a really cool library, and we're going to use it for some more advanced applications that we'll talk about later on. Neo4j Blue, this is again what I was talking about a little bit earlier, where you can expand nodes and relationships between them. We have, if you look at this particular example, the things you can already infer from it, there's 4 risks, 4 of them affect one asset. So we might want to target our mitigation plans towards this asset, do some more analysis. Why is this asset so risky to us as a business? Is it worth even keeping it around? So there's these questions you can then ask, given this exploratory data analysis. Neo4j's just been announced recently that it's actually going to be introduced as part of a consumer product. This will provide some sort of like dashboards, business insider or business insight information. It's really useful actually for conveying information to people that make decisions. So David, for example, the CISO, can look at these charts and see sorts of information, make decisions off them. It's also worth mentioning, like before, we actually get to keep a lot of the visualizations that we have. So we have a risk matrix on here, for example, things that we had in our traditional risk register. We don't get rid of them. We still keep them around. They're useful, but we add additional information to help supplement those decisions. Here are some example queries that I've run, just to show you some of the patterns that you get and the questions you might ask and why graphs are quite useful. These are the relationships between vulnerabilities and risks on the left, and then the business areas and assets on the right. So the business areas are green, and the assets are brown. And as you can see, you can always start asking questions. Like if you notice down at the very bottom, one of the business areas has loads of assets attached to it. Why is that? Like, is that because, say, the security team owns the risk register, they do a lot of input into the risk register, the security team is very aware of security assets? Is that why there's more assets attached to this? Like, is it just, do we need to look at more business areas properly and identify assets that may be affected by them? You know, there's these sorts of questions that you can then ask just by looking at a view of a graph that you don't get from a spreadsheet. So that's really cool that you can start to draw these insights. There's also another query and another thing that you can look at from risks that we think is quite insightful. This is actually being able to view the blast radius of a risk. This is super important. Say, for example, a traditional risk register, you have a risk analyst that puts in, I don't know, a risk for Phil's laptop. It's impact rating of 2, probability rating of 2. If Phil's laptop gets stolen, it's not really that big of a deal. It's a traditional risk analyst will see it in the green. They'll be like, okay, fine. That's basically not even a problem. We've got to focus on the risks in the red and getting them down, so we can't worry about this. Actually, the blast radius might be more impactful in the sense of it would be easier for people to see, say, Phil's laptop. If they gain access to Phil's laptop, they'll have access to loads of support tooling. They may be able to mess with that and actually really have a massive impact on business outcomes. This is kind of the notion that we're trying to get when we talk about blast radius, being the number of assets or business units impacted by a single risk. And we're able to define this quite well through incorporating other data sets that we'll talk about a bit later. Yeah, I just thought that was a really important visualization and a really important thing that we can see whenever we're making mitigation plans and targeting them, and actually thinking about risks is not what we would expect and just see a number. It's actually a complex problem, and a complex problem requires a complex solution. Okay, what are some more applications that we can do with this new graph model? I've gathered 4 main applications that I thought were pretty cool during my time at Neo4j. Identifying crown jewel assets. So these are assets that are quite important. If the business loses them, that's not great. Most damaging attack vector. So what is let's say the minimum amount of assets the attacker could cause maximum damage to the business for? Similar risks, so risks that are potentially duplicated. We want to avoid that as much as possible. And then severity prediction. Can we actually predict the severity scores based off the other data in the risk register? Can we predict what those scores are going to be? So if we look at the crown jewel assets, we've defined them in our risk register as assets that have a high average impact. So say Phil's laptop has 3 risks associated with it, all have impact 5. This is going to be an important asset to the business. We should target our mitigation plans towards this asset, and we can easily identify this with a graph. The most damaging attack vector. By defining things as a graph, we can start to do more advanced graph algorithms. Say each of these edges here have a weight associated with them, so a score. An impact rating from 1 to 5 is what we've used. And you can run an algorithm, say, to sum up all these values and find the path that would give you the highest sum. This is pretty much what this algorithm is doing in a high-level view, and it's able to find what is the maximum damage that the minimum number of assets could cause. This is using Neo4j's graph data science. I think it's quite cool. Again, it's a different way of targeting your mitigation plans. You're not looking at each risk one by one. You're actually looking at, okay, wow, this is a problem. We've got loads of assets. Like, if these get taken out, it causes a lot of damage to the business. And it's just a different view on the data. Similar risks. This is a lot bigger of a problem than I had initially thought. A risk register can just be, I don't know, you can have 400 risks in a risk register, but actually not know how many risks there are to the business. A lot of time risk analysts spend just cleaning out the risk register, removing duplicates and things like that. Through modern natural language processing techniques and Neo4j similarity search, we can do, say, each sentence will get encoded as a vector, so just a list of numbers, and then you compare their similarities using a cosine similarity metric. And this is able to identify like similar sentiment. So in this one, it's basically the same words. I think Phil had mentioned previously, say even if it was about Will's laptop or it's about a laptop, it's the same notion, it's the same sentiment that this is saying, and then that will be captured as a similar risk, and it will greatly, greatly reduce the time that you have actually removing duplicate risks. Risk severity prediction. People still make decisions based off a risk matrix. Whether that's good or bad, we need to make sure that we predict the correct score. And one of the tools that we thought might be useful for that is in predicting it. So, for example, you can train a machine learning model. Given the vector embedding, so the sentiment of the text that you've described, given the neighbors of that risk, so the nodes, things like the assets, and stuff like that, can we actually predict the impact and probability rating? And we were able to do it fairly accurately. Actually, one of the cool examples in Neo4j was one of the risks was predicted a 3 by the model, and actually it was an impact rating of 1. But whenever we investigated this further, we found that actually a mitigation plan was put in place to reduce this risk. But that hadn't been accurately captured in the data. And so our model was kind of thinking, where's this going? So it's a pretty cool, again, not as a replacement for a risk analyst's professional judgment. Really, at the end of the day, they're the ones that are skilled enough to make these calls, but hopefully it will reduce some sort of subjectivity and make sure that you're putting in all the correct information, kind of as a supplement to making these decisions. Cool. What are the business impacts that this will actually have? We've got a couple of main ones. So it will reduce subjectivity, remove duplication, increase trust, and people will be able to gain a deeper understanding of risk. This is particularly useful just by looking at it in a graph view. Yeah, in Neo4j actually, is I mentioned before previously that we flagged risks with strange severity scores, and dashboards have also been used in the weekly reports. They're still used to this day, and people are able to look at them, look at these graph views, look at the same metrics that they would have seen before to actually, understand more about what's going on deeper. And again, there's much excitement about what other questions we can answer using a graph. That's kind of like the main takeaway for us, is you can ask questions about it. You don't just see a massive table and go, yeah, I know what that's saying. It's just a bunch of risks and their scores. Actually, you can see a lot more meaningful information. And a quote from David that I really like that encapsulates this well is, "A graph database breaks the constraints of the tabulated format. It allows the analyst to understand wider relationships, giving a richer understanding and generating more questions." It's also worth mentioning, I thought, talking a little bit about the implementation details, how we've done it whenever I was there. We've actually still got our data currently in a spreadsheet. We're going to talk about the benefits and the negatives of this. But currently right now, you can do that. If you don't want to fully switch to graph databases yet, you don't have to. So we've got an ETL tool. We're using Apache Hop. We convert this structured data, we get it, and then convert it every 24 hours through GitHub Actions into the Neo4j graph data. So we model all the relationships and nodes and things like that automatically in there. And then through Neo4j, we can use Bloom for analysis and graph data science again for more analysis. And this is all deployed securely behind some cloud infrastructure that produces the dashboards at the end so that people can see the information they need to make decisions. Why is this approach good? Well, I mean, it's pretty immediately obvious. A graph database is new. It's not just a spreadsheet. Everyone knows what a spreadsheet is. It's like, here's a cell, let's fill it in with the information it needs. A graph database is more complex and it takes time for people to get used to. So this approach allows people to kind of dip their toes in without jumping in the deep end. You can run some queries, try and do some analysis on it first before you start inputting data into it. I think there are a couple of negatives though that should definitely be considered before doing this, and that it restricts unstructured data potential. What I mean by that is stuff like the time series data, things that are really, really hard to store in a normal tabular graph. These sorts of data points just get lost. So you lack the immersion that you would get if you fully adopted the graph database. Again, lacking immersion, you still think of things sort of in a tabular format. You don't actually think of them as a graph if you're doing this hybrid approach. It's still great for analysis, but we're really ultimately aiming to move towards that graph database. That's where we want to go. More difficult to maintain the hybrid approach. This is quite a lot of steps in this. It is more difficult to maintain and adapt. Where do we want to go from here? Well, we want to aggregate a couple of data sets. Again, this notion of blast radius is super cool. We want to develop it further. So we want to use asset registers or CMDBs. How can this sort of modeling the asset hierarchy, say Aura console belongs to Aura, which belongs to like this team and this team, how can we increase the blast radius and the knowledge of that to better tailor our mitigation plans? Vulnerability prediction, how can we, given a risk, how can we predict what vulnerability it has? And can we even do that? That's a question we were looking at towards the end. And then risk appetite. How can we extract a sentiment, so maybe a sentence or a score, to resemble the risk appetite based on this graph? That's something that we think we can answer using a graph, and it's something that's worth looking into. Cool. Well, I hope you've enjoyed that little presentation. I just wanted to say that we will be publishing this data set that we've used in this presentation, so you can have a mess around yourself, but hopefully it was insightful.